Okay, this video is a review for chapter 3.2, which we did that before spring break. So this one, they ask you to find the maximum or minimum values of the system and the location. So for most of this, if the graph is given to you, then you will set the table and plug in the points of the graph, the vertex of the graph, to the given equation, which will help you to find the maximum and minimum values. So once you find the maximum and minimum value, you can see what location they are. Some of the graph will be bounded with vertex enclosed, and some of them would be not bounded. So we did some example together in class. So the first two questions, the graph is given to you, so those are a lot easier. The first one, they have a z equation here is a bounded graph that have all the vertices provided for you. So we will set the table with the equation here, the z equations, and then we list all the points. Usually I start with the smallest x to the biggest x, so it would be in certain order, and you just plug in the x and y value into that equation and get those values. So the smallest one represents the minimum value. So the minimum value is 5 at location x equal to 1, y equal to 1. The biggest one here is 35. So that's your maximum values at the location x equal to 4 and y equal to 9. So this is pretty straightforward. The second one is actually not bounded. I know it's not very clear here, but it provides you with all the points here. So again, I will list the equation along with the points starting with smallest x to biggest x. Use those x and y value, plug into the equation, and this time I don't have maximum value because the graph's supposed to go forever here and forever here, so we don't have an endpoint for the biggest number, but we do have a minimum number, which is 18 is my minimum, right? And the location would be at 0.90, meaning x equal to 9 and y equal to 0. So the next part, this is a different one. So again, you plug in the point to the equation, and for this time we have two numbers that are the biggest. So both of them would be maximum, and when that happens, what it means is the maximum value is 44, and the location is going to be every single point on this line segment between these 2 points that we found here. So this is a little bit different, and the minimum value is 15 at 0.150. All right, and this is a bounded graph. So to go one step further, the next one would be a little bit more difficult because the graph is not given to you. So you will need to use this system and use what you learned from the last sections to do the graph on your own, find out which part is the overlapping shaded area, and once you get that, you need to find those vertices endpoints. So these 2 points are pretty easy to find, and this point is also pretty obvious, but for this particular point you're going to need to find the intersecting points of these 2 lines, right? So basically you're solving for x and y value of these 2 lines. So one is x equal to 3, one is x plus y equal to 6, and you use the x value plug in here to get your y value. So you figure out this is 3 and 3. And of course, if you want to double check, you can use your graphing calculator and plug it in to find the intersecting points. So once you have all the vertices, you can do the same what you just did. Set a table, put the equation there, and plug in each of the vertex points. And then this particular one asks you to find the maximum. So the maximum is value is 15 at the point 3 and 3. All right. So the next question, same thing, they didn't give you the graph, and this one asks for minimum, which is reasonable because this is unbounded, which means they have no maximum. So again, you need to put those lines and graph it. Once you graph it, you need to find all those points, right? So this one is easy to see, this one is easy to see, but you need to find the intersecting point of these two linear equations. So you will need to solve that. You could use matrices with the RREF on your calculator to find that intersecting points. Once you have all the points, like you grab it, you get those points, and then you can set this table with the equation, plugging in all the points you have to see which one is the smallest. That's your minimum. So your minimum value is c equal to 8 at the point 4, 0, meaning x equal to 4 and y equal to 0. So that's 3.2.